Welcome, everyone. Thank you all for coming. I hope you all enjoyed that great keynote. I'm really excited to kick off another year of droidcon London. I am Adam McNeilly. I am a Google developer expert for Android. You can find my Twitter handle up on the slides, or the slides were just auto-posted, so if you're curious and following along or finding them later, that's where you can go get them. And today we're going to talk about composing with confidence. So this talk really starts off with a key point that testing is important. And I'm going to kind of gloss over this. I think a lot of us know this or have heard this at this point, but we always want to test our software to make sure we're shipping quality products, that everything works the way we expect it to, and we don't have any hiccups along the way. And I'm really referring to all sorts of testing here, from manual testing to pure unit tests to full end-to-end integration tests. Although for this talk, we're going to focus on the last two. Because I'm sure you may have heard once or twice, but there's this new UI framework for Android called Jetpack Compose that everyone is talking about, and with new tools comes new responsibilities. So whether you're a person who has a lot of experience writing UI tests for your application today, or you've never written a UI test before, this is a great chance for us all to be on the same page. Whether you're a new developer or a seasoned developer, testing with Jetpack Compose is brand new to all of us. And so that's what I want this talk to be about, is understanding what sort of APIs and opportunities we have for testing our code that are existing within this new framework. So we'll start off with the basics, but we'll get into some more advanced stuff at the end. But let's first go through sort of the getting started guides that Google made us to get us up and running with testing our Compose apps. And then we'll look at some real world examples later on. So what's cool about Compose testing that was a little different from sort of the Vue framework is we've actually got two different options we can consider for our Compose testing. We can test individual components. So if you have a simple card view or a button that you want to validate, that's very easy to do in Compose versus in the old Vue system. If I want to fire up a specific view, that's hard. But then we can also test full activities. We could test a full application flow, like signing in, viewing your home screen. We can do all of that stuff. And we look at a similar example. And how we set that up for these two options changes a little bit. So when we write our test, now this is something that exists within the Android test folder. There's a test that I'm going to run with a physical device or emulator of some sort. And what we need to do is we need to create a JUnit rule. So in the most basic example, we can call this function called createComposeRule, which is a really cool thing that creates a component activity that is just a Compose container, and then you can render whatever you want inside. So this is what I mean. If you want to render just a button and verify how that button behaves, this is very easy to do. It's kind of just this blank container for you to add whatever you want. Or you can call createAndroidComposeRule, and you can specify an actual activity you want to start up. I should point out, I don't really talk about this later, but with this one, the other thing that's cool is it's not just individual components, but any composable function you can render. So if you have a screen deep into your application's flow, instead of starting up your app, logging in, clicking on this home screen tab, going into settings, you could just have your Compose test rule render your settings screen. And so you don't have to deal with all the work that leads up to the settings screen. And we'll show examples similar to that later, I guess. And then once we've created our Compose test rule, it's as simple as just calling compose test rule.setContent and whatever we want to render inside. So here I'm just showing I want to render an enabled primary button. And that's it. And so let's talk about, now that we know how to put something on the screen, that's the first point, let's talk about the recipe we have when we're writing a UI test. And there's really three things we need to think about. Once we've put stuff on the screen, we need a way to find that component. So here we'll just say I'm going to call on my test rule onNodeWithText test button. And I'm going to assume that this will return me that button node within my screen. And then I either want to make an assertion. So here I'm asserting that the button is enabled state. Or I'm going to perform an action. So I'm going to call perform click. And we'll look at specific examples, but this is the recipe that we want to follow, right? Find the component, make some assertion, perform some action. So let's talk about finding components with Jetpack Compose. So the easiest way to do that, or the most basic way of doing this, is when we have compose test rule, we can call onNode, and we can give it some matcher. And there are a million of them out there. There's has progress bar range info, or is dialog. There's also has text, has content description, etc. But any matcher you think of, or custom matcher you write, would go in here. And thankfully, Compose actually has helpers for common matchers we might use. Like instead of onNode has text, like has text being a separate function, it's all one thing, onNode with text. There's also like onNode with content description, onNode with test tag. We look at tags in a little bit. And similarly, if you expect something to appear more than once, there's symmetry for like on all nodes with some matcher. And then there's assertions. And it follows a similar pattern as matchers. Once you have reference to your node, once you've called compose test rule on node, whatever you need, you just call assert and you give it some matcher. So here we could say assert has text, test button, or assert is enabled. And similarly, for common assertions and way more than matchers, there's helper methods. So I can say assert text equals, assert is enabled, is not enabled, is displayed, is not displayed. There's a whole bunch of these. Anything that you expect to assert is in there, and if it's not, you can write your own custom matcher. So if you're making your own custom component, you can make your own matchers to validate these in production, or in your tests anyways. And then there's performing actions. And these are actually a little easier because it's rare that you write like custom actions. Pretty much anything you need to do is already like a framework level capability, right? So we can just say like perform click or perform text input. If you do need to do something fancy, chances are like you're dealing with swiping, like there are compose actions for swiping or even gesture input where you can specify everything you need to do. And if you're interested, there's this really cool cheat sheet. Now I know you can't read this, and that's fine, but if you go to the compose testing docs, there's this cheat sheet that shows you all of the matchers, assertions, etc., that are available out of the box, those helper functions I talked about. But remember, for like matchers, you can always override your custom one, but if you're curious, like what is already there that I don't have to customize, this cheat sheet's really helpful. And the last like intro thing to talk about, I want to talk about like test tags. So an example we looked at earlier was, oh, I want to find a button based on the text that it has. But this can be difficult for a number of reasons. Maybe the text on the button changes. In locale, you're going to have different strings. And unlike the old view system, we don't use like view identifiers in the same way. Like on an XML view, I have an ID. So in my espresso test, I would do on view with ID, blah, blah, blah. In Compose, we don't get that out of the box, but there's a really easy way to do it with the test tag modifier. So I could create like a login button, give it some test tag, that's the hard-coded string, login button, and then in my test, I can easily do onNode with tag, login button. So I don't have to worry about any state of like what the text is, what locale I'm in. This test tag is always going to be the same. So if you're dealing with components you expect to reference in your test, highly recommend using something like this. It will help you out a lot. So that's the quick intro. That's everything you need to know from the test recipe. Find components, interact with them through assertions or actions, and then keeping in mind test tags. So now we can get to the good stuff, and we can look at some real-world testing examples. I'm going to start with a very simple, contrived example that maybe you wouldn't actually write a lot, but it's a great way to see how we can build these sort of incremental component tests in Compose. So let's go back to our primary button. And this is going to be a button with 3 properties, which is just the text, some action that happens when you click it, and whether or not it's enabled. And I want to focus on this enabled state. So let's say we want to write a test that when the button is enabled, this click callback should be triggered. When the button's disabled, it should not. And this is what I mean. It may be a contrived example. I don't know that I would test a button like this, but I'd want to show that you can do this in Compose very easily. So here's our setup. It's similar to what we looked at before. We set up our primary button test with our create compose rule, and we're going to write a test called handle click when enabled. And inside that test, we're going to have a variable for whether or not the button was clicked, which we're going to default to being false. And then on our compose test rule, we're going to set the content, which is a button that has some text. When it's clicked, we're going to flip that flag to true. And then we also specify that the enable property for the button is true. And then, so the second part of this test, we will call our compose test rule, find node with text. I really should have used my test tag. That's on me after I just talked about it. And then we're going to perform a click, and then we're going to assert that that flag we had was true. And basically, if I wanted to change this, what I could do is I could make the enabled state false, and then here I would just like assert false was clicked. And again, maybe a very contrived example. I think buttons enabled state is something we all just kind of assume works, especially if I'm using like a material button. But I wanted to show like it's very easy to take like a super small component as simple as a button and make sure your button behaves the way you expect it to. So let's take it a little step further and maybe look at another slightly bigger component that we might want to test. So this is a screenshot from a sample app that I work on every once in a while. I call it Pocket League, which is very washed out by the light, but it's a like esports results tracking app. And it's got this feed of like recent matches, and that's what I want to talk about. There's this card here that shows you like a recent match between two teams. And a piece of functionality I want to call out, there's a blue team and an orange team. The blue team is listed first, and if they're the winner, or whichever team is the winner, they're going to get this little trophy icon next to their name. So this is a piece of like app functionality that I want to make sure this works. I want to make sure that the winning team is the one that gets the trophy icon. So let's walk through how we can do that. Our test setup here, we'll look at this for a second. It's very similar to the other one. We just call compose test rule.set content. Here I'm applying my theme just so I can see how it looks. And then I render the match card with some test display model for the blue team winner. And actually, I didn't show this with the button, but what happens when you run this is you get something like this. And we can see this is the component activity, that sort of stub activity I talked about earlier, and it just renders the card inside this stub activity that I can then interact with or make some assertions. Now, one of the hard parts about this test, if I weren't the person who wrote this code, is thinking about like, how do I verify this trophy icon? How is that actually working? Like, is it a separate image view? Is it part of the text? Blah, blah, blah. And if I didn't know that, let's talk about how I could debug something like that. In our Compose UI test, there's really helpful debugging tools already built in so that you can take your test rule and then starting at the root, or honestly on any other node, you can call print to log and give it some tag. And what this is going to do is print out basically a view hierarchy of everything that's within that composable content. And then from there, you can go through and find what you need. So I trim this down, but you can see here, we've got this node that has the tag blue match team name. It's got the text knights with winner in brackets, and then some other stuff. And basically, to fill in some gaps, what's happening here is that icon was not like a separate image view. It's actually a cool thing that does like an inline icon. And the way it works is it looks for this keyword, winner, in brackets, and then basically replaces that keyword with the icon in real time. But what I can do is I can assert, if I have this text, then I know the icon's there. Or at least I know it's there. I may not like be able to visually see that, but my test could verify that. So here's how we would write those assertions. I'd find that node with the tag, and I would just assert text equal knights with the bracket winner. And then to make sure that the blue team is the one that has the winning icon and not the other one, I want to write the opposite assertion. For the orange match team, we're just going to assert the text equals G2 esports, but no winner brackets. So that's one way we could test an individual component and see how we can just write those assertions ourselves. But with something like that, with this rendering logic, there's actually another option we could look at that I find really cool, which is something called paparazzi, which is a way to render your Android screens without a physical device or emulator. Now, I'm not going to talk about it a lot because there's actually a presentation about this from John Rodriguez later today. It's in the booth room at 3:20. Definitely recommend checking it out. But let's look at a sample of what this is. So with paparazzi, it's basically under the hood, uses all the same things that like the preview tool in Android Studio uses. So it can render this stuff without needing to run on a device, which means it's going to be a little faster for us. So we create this paparazzi rule, and here I'm using the default, but it's really nice. You could specify the device type, the device theme, locale, all that stuff. And then I'm just going to call snapshot with some composable content that I want. And it's going to render a similar thing as before. This is actually the output of that test. We see this screenshot, and then what we do with this is this gets saved in source control, and anytime I make changes, I can basically run a verify that will re-render the screenshots and compare it to the old version. And if I change anything that breaks the way this UI looks, then I'm going to find out about it. And the other cool thing about it is you'll get these like diffs in your source control as your stuff changes. So I showed a simple example of like, here I'm not really changing the component, but I changed like the display model. So you can see on the left side, we have the team knights for both. And I realized like that's fine because it's just a test, but maybe I want it to be a little more clear of like there's two different teams here, so I changed the name, but you get this really nice before and after diff in GitHub. And this is really nice as a code reviewer. If someone changes something, I can easily look at this and see what is different. And if you run these and there is like a failed diff, I do think Paparazzi gives you a similar output to this of like what was expected and what the actual screenshot looked like. So with that, like I think it's really helpful, but kind of just posing questions about, well, what is the right tool for testing small components like this? Because Paparazzi is great that it has that pixel perfect validation, but it requires you to verify snapshots. Sorry for the typo. I found this like 2 minutes before the talk happened. Like I have to look. I can write a snapshot test to verify the blue team gets the icon, but then I also have to look at it and make sure like it was the blue team that got the icon, right? And then our snapshots can change often. Like sometimes we just change components, naturally, product requirements, etc. And it means re-rendering a whole bunch of new screenshots, which creates a whole new diff in the repo. And that can be a lot of noise, but can still be beneficial. But what I wanted to point out with this is like when deciding between writing your own like composed UI test using those APIs versus Paparazzi is consider like functionality versus rendering. Like if I am testing click functionality or navigation, etc., then I want to use the composed libraries. But if I just want to test that something renders a certain way, Paparazzi is going to be super helpful for that. And there are other snapshot libraries out there that are worth looking at. So now that we've kind of understood some small stuff, let's test something a lot more complicated and consider testing a login form. And this was just an example that came to mind. I think forms are a great example because we have both text inputs and buttons and verifying navigation. There's a lot of things that once we understand how to test a login form, we can then go away from this talk, scale that to all sorts of portions of our app. So here's a sample of a login form. What's cool about this is we notice that as we type, the button is disabled until I enter both username and password information. And then I'll be able to navigate forward, and it will just go to some stub home screen. Not a complicated project at all, but shows what we want to test. So let's look at the setup. Very similar to what we looked at before, but I should point out this is a little different in that we have like create Android compose rule here, and we want to launch like our main activity. So this is going to start up the app the same way it would if the user did. And let's walk through all of our steps. And we'll look at them one by one, but very similar to what we've already seen. Verify the login button is disabled, so find the node with the tag, assert is not enabled. This is one of those helpful assertions that I talked about. And then we're going to type in our username by calling perform text input. Then we're going to type in our password, Hunter2, most secure password there is. And then we're going to, after we've done all that, verify the button is enabled now. We're going to click it by calling perform click. And then we're going to make another assertion for the home screen label, and assert is displayed. So it's really nice when you break it down into these individual steps. It doesn't sound as complicated as I think testing appears when you first look at it. But it does still get a little complicated because what you're left with is a test that looks like this. And that's not bad. It works, but I'm the kind of person who really loves when I can like scan code really easily and see what it does. And this can't do that. And another problem with this is like if I change something about like my login button, if I change the tag, for example, even, I have three or four different spots within this test alone that need to be updated, let alone any other test that I have. So let's talk about how we can not just write composed tests, but we can write like scalable, maintainable composed tests that are going to help us a lot. And one way to do that is through something called test robots. Now, sometimes we think in production code, if we're going to share logic across multiple things, we pull that out into a separate component. And we don't really talk about doing that for tests, and I think we should. If I have multiple tests that are interacting with the same components and the same pieces of functionality, I should pull that out so my tests can share it. And that's counterintuitive when we say like tests should be isolated, but I think this is a little different from that. It's just that logic we're going to do over and over again. If I'm typing text into the same input in multiple tests, like that should be isolated. So let's talk about how we create this robot. We're going to create a class called login_screen_robot. It's going to take in our compose test rule because the robot needs to know how to find and interact with nodes. And what we're going to do is we'll make a private val for each of the components that our test is going to interact with. So username input will be compose test rule on node with tag username text field. And I write this once. Any other time I'm going to deal with the username input, I can reference this variable. So this is nice for what I said. If I change the tag for any reason or some other way of identifying the username input, I change this one first line, and all of my tests should still pass. So we'll do this for our two input fields and our login button, but this would be whatever you have on the screen. And then I make them private, so instead I can write functions that are public that describe exactly what our test is doing. So we'll write a function called enter username that takes in the username we want to enter, and then we'll perform that text input on our username. And the same with password, and what's not pictured here, but there's similar functions for click login button, verify login button is not enabled, things like that. And then, brief tangent, but we can look at some Kotlin magic to make this really nice to work with, which is let's make a function called login screen robot that takes our compose test rule and then some block of actions that we perform on a login screen robot. And then what we're going to do is we're going to create the robot and then invoke those actions. I know it sounds confusing what this is doing here, but what it means, what it looks like, is we can write this. So this is almost the exact same test, but instead of all of those compose test rule on node blah, blah, blah calls that are really hard to scan, we can say we're creating a login screen robot. I want to verify the button's disabled, enter username, enter password, verify the button is now enabled, and click it. And this is way more readable and easy to scan. It becomes way easier to write other tests for like error scenarios because all these functions already exist. So I'm going to get things like autocomplete, and it's going to be really helpful. And again, if I change anything about this, if I change like information about the button, I can just go modify my robot. All of my tests remain unchanged. And so this is the full test that we get. We'll have the login screen robot, but we could do a similar thing for the home screen robot. Verify label is displayed. I also like this because, again, if you're writing a full like end-to-end integration test sort of thing, you're going to get like, you can basically see how that functionality is split up from the login screen robot to the home screen robot. If you have other screens you're dealing with, it's kind of that nice visual chunk, like from this screen to this screen to this screen. So that was a quick example of testing a full flow. And like I said, while it's just the login flow, you've learned how to find components on the screen, how to interact with them, how to test like navigating from one screen to another, that this can really scale to a lot of projects. So if you're curious of seeing some of this in action, there's a couple project links that I can share. Feel free to take a picture of this. The second one is really the one I kind of wrote for this talk that is like very isolated to just the login screen. The Pocket League project is my side project that has a whole bunch of other things, but there's definitely some interesting test stuff there that's worth looking at. And I'm earlier than I thought. That was it. Thank you so much.